In today's lesson, we're going to be looking at problem solving with systems of equations. Today specifically, we're going to be solving with elimination. We could do also some of these with substitution, but since we've been practicing on elimination, that's what we're going to be doing. So let's look at an example here. Sam spent $24.75 to buy 12 flowers for his mother. The bouquet contained roses and daisies. The cost of a rose is $2.50, and the cost of a daisy is $1.75. How many of each type of flower did Sam buy? We are going to be writing two equations. One equation is based on the cost. We know the total cost, and we know the cost of the roses and the cost of the daisies. The other equation is going to be based on the number of flowers. We know that there's 12 flowers and that he bought both roses and daisies. Now, since we're talking about roses and daisies, I'm going to use the variables r and d so we'll know which is which. The first equation, just based on the number of flowers, is pretty simple because if you bought 12 flowers altogether and some were roses and some were daisies, it's just going to be the number of roses plus the number of daisies is equal to 12. That's our first equation. Our second equation is going to be based on the cost. We know that altogether he spent $24.75, but that there was $2.50 for each rose, and there was $1.75 for each daisy. So if you add those together, it's going to equal a total of $24.75. So one equation based on the number of flowers, one equation based on the cost. Now, since we've been practicing elimination, we're going to solve this with elimination. You could also do it with substitution, but this is what we're practicing today. In order to solve with elimination, we need to create opposite coefficients. So either our r is going to have to be a negative 250, or our d is going to have to be a negative 175. So you could do either, but I chose to multiply the first equation by a negative 250 so that our r, or the number of roses, that coefficient will be opposites, and they will cancel each other out. So if you multiply all three terms by a negative 250, that is going to give you negative 250r plus a negative 250d, and that equals a negative $30. The second equation we don't have to do anything to because we have created what we call opposite coefficients right here. 250 and a negative 250 becomes 0, so we say that's eliminated. That's why we call this elimination. It's eliminated. Now if we were just to solve the rest of the equation, a negative 250 and a positive 175 is a negative 75 for the number of daisies. This is supposed to be negative. And negative 30 and 2475 would be a negative 525. Now if you divide both sides by negative 75 cents, we will see that the number of daisies is equal to 7. Now, to figure out the number of roses, if we go back to this equation where we knew the number of roses plus the number of daisies was equal to 12, and we know that there are 7 daisies that we plug into here, what do we add to 7 to get r? We just subtract 7 on both sides of the equation, and we find the number of roses is equal to 5. So he bought 5 roses and 7 daisies. In the next example, the Thunder scored a total of 80 points in a basketball game. I can move that a little bit. Against the Bulls, the Thunder made a total of 37 2-point and 3-point baskets. How many 2-point shots did the Thunder make? How many 3-point shots did the Thunder make? So again, we have to make two equations. One equation is going to be based on the number of 2 points. We have two variables here. We have 2 points and we have 3-point baskets. And we know that altogether they made a total of 37 baskets of 2 points and 3 points. So we have to decide what variable we want to use for 2 points and 3 points. What I decided to do is just use x and y. You could have used, they both start with t, I guess that's why I did that. So the number of 2-point baskets right here plus the number of 3-point baskets here is equal to 37. And I just used the variables x and y, x to represent the 2-point baskets, y to represent the 3-point baskets. And then we want to make an equation based on the number of points. Well, there was 80 points altogether, and 2-point baskets are worth 2 points. And 3-point baskets are worth 3 points. So I just attached the number of points that each type was worth, and here's our two equations. Now to solve by elimination, we need to create opposite coefficients. So we're either going to be multiplying this top equation by -2 so that the 2-point baskets will cancel out, be eliminated, or we can multiply the top equation by -3 so that the 3-point baskets can be eliminated. Either way, you're going to get the same answer. What I chose to do was to multiply the first by a -2. That means I'm going to multiply all 3 terms by a -2, which makes a -2x plus a -2y, I got in the way again, and a -74. Now we've created our opposite coefficients. Our 2-point baskets are eliminated, and that just simply leaves us with y is equal to 6. We didn't have a one-step equation there. That made it easy. So now we know the number of 3-point baskets. We know altogether the 2-point baskets plus the 3-point baskets was equal to 37 baskets, and they scored 6 3-point baskets. So the number of 2-point baskets, we would just subtract 6 on both sides of the equation, and that would be 31 2-point baskets and 6 3-point baskets. And another example. Tickets at a particular movie theater have different rates for adults and children. On Sunday, the theater sold 9 adult tickets and 2 child tickets for $151. The next day, the theater sold 8 adult tickets and 7 children tickets for $176. What was the price for the adult ticket and the price for the child ticket? In this particular example, we have 2 different days. We have Sunday and we have Monday, since it says the next day. So we're making an equation for each of the 2 days. On Sunday, 9 adult tickets and 2 child tickets for a total of 151. So we could write 9A for the adult tickets, we could write 2C for the child tickets, and that could equal 151. On Monday, it was 8 adult tickets, so that's 8 times the price of the adult tickets. 7 children's tickets, which is 7 times the amount of the child's tickets, was equal to $176. So this time the 2 equations was the 2 days. That time I used A and C. Let's see what I did on my PowerPoint. I did X and Y, but you could have very well used A and C. If I were to do it again, I would use this A and this C. But X and Y, again, the variable doesn't matter as long as you know what each variable represents. Now for this one, in order to eliminate, we're going to have to multiply both equations by a number. So we could either multiply the first equation by -8 and the second one by 9. That would create a -72 and a +72, and that would be eliminated. Or we could multiply the first equation by -7 and the second equation by a +2. That would create a -14 and a +14, and that would be eliminated. You could choose either one. What I chose to do was to multiply by 7 and -2. So if I multiply each term in the first equation by 7, that would be 63x plus 14x plus some number that I'd have to figure out. And then -2 on the last one. That is going to give us these 2 equations. We have 63x plus 14x equals 1057. There's that number. When we multiply the second equation by -2, we get a -16x, a -14y, and a -352. We have created our opposite coefficients that get eliminated. Now we have a +63 minus 16x, and that is going to give us 47x. And 1057 minus 352 is 705. Now to solve for x, we divide both sides by 47. And we find that the number of x, which represent the number of adult tickets, if we were to use the variable a, was 15. Now to plug that back in, we're either going to plug it into the first equation or the second equation. I chose the first equation, so we know that x is equal to 15. So if we plug that in right here, if we follow our order of operations and we do our multiplication first, 9 times 15 is 135. We've created a two-step equation. We locate the variable. We move what's not attached to the variable first. We're going to subtract 135 on both sides of the equation. And then we're going to divide by 2, and we get 8. So now we know that the number of adult tickets was 15, and the number of child tickets was 8. Oh, $15 and $8, not the number. My apologies. You buy 7 bags of gummy bears and 3 bags of chocolate, and your total is $22. Your friend buys 3 bags of gummy bears and 1 bag of chocolate, and her total was $8. What was the price of a bag of gummy bears and a bag of chocolate? So we have an equation for you, and we have an equation for your friend. 7 bags of gummy bears, 3 bags of chocolate. Now, if I were to do this, I would probably use 7 gummy bears and 3 bags of chocolates for a total of $22. You could use X and Y again, but sometimes it makes it more understandable if you're using a variable that represents what you're doing. Your friend buys 3 bags of gummy bears, so that's 3 bags of gummy bears, and 1 bag of chocolate, and she spent $8. So there are your 2 equations. My PowerPoint here, I probably used X and Y again. If I were to do it again, I would do G and B, but again, the variables don't matter. Now, if we look at this, if we are going to solve with elimination, right here, when I look at this, I know that if I can make this a -3, it would be eliminated. So I'm going to multiply -3 times each of the 3 terms in the second equation, and that is going to give me a -9 and a -3y and a -24. Now we can solve it because the y has been eliminated, or the number of pieces of chocolate, or bags of chocolate. That leaves us with a -2x and a -2. And when you divide both sides by -2, then x is equal to 1, and we have to remember that x was representative of the bags of gummy bears. Now we can plug back into either equation. I chose to plug back into this equation. Let me erase all this extra stuff here so you can see it there again. Here was the second equation, and if I know that 1 is x, I can plug that back into the equation, use my order of operations. 3 plus y equals 8. Subtract 3 on both sides, and we find out the bags of chocolates are $5. $1 for gummy bears and $5 for chocolates. I hope that helps you with creating equations and solving systems of equations by elimination.